all work and no play makes Jack a dull boy. To make sure his mind stays sharp, Jack must maintain a nice ratio of his work to play. To stay smart, Jack has been learning, and so have you. You have learned that ratio is actually a relation between two quantities of the same kind. But can two ratios be compared? Should they even be compared? Yes, and you'll see why. Suppose I have a painting in my lounge whose dimensions are in a ratio of 4:3. Some people might be okay with this, but I want to replace it with a bigger one. Maybe I can just increase the breadth to, let's say, 50 from 30, or the length to 70 from 40. Yikes, you can see that this is not working. Who would want to hang these paintings? They're all stretched out. But what even went wrong here? Well, since we only increased the breadth in the first one and the length in the second, that messed up the relationship between the length and the breadth of the painting, or in other words, the ratio. How about scaling both the length and the breadth to twice as large as the original one? That certainly is bigger but beautiful at the same time. Why did it work this time? Yeah, third time's the charm. But more importantly, because it has the same length to breadth ratio as the original painting. Both are just multiplied by 2. Hence, it is pleasant to look at. Equal ratios seem to matter a lot, don't they? This doesn't just work for scaling up. You'll need equal ratios to scale it down to a much smaller picture, 5 times smaller to be exact, also retains the same quality due to the equal ratios. In fact, any measurements that can be simplified to the ratio 4:3 will maintain it. 12:9, 20:15, 32:24, and so on. The point to remember is, whenever this happens, we say that the ratios are in proportion. Simply put, a proportion is an equality of ratios. That's really it. Since we've literally symbolized everything so far, why should proportions be any different? The symbol used for denoting a proportion is this, the double colon. In general, if we have two ratios A to B and C to D such that they are in proportion, we can write it like this. We can even write an equals to sign instead because this is what proportion means. There is an interesting and in fact very useful property linked with it. See, the very first and last terms of this proportion are called extremes, while the middle ones, the second and third terms, are called means. Since ratios can be expressed as fractions too, so this can be written as A upon B equals C upon D. On cross multiplication, this is what we get, which basically says that the product of the extremes is equal to the product of the means. What a fun rhyme! Product of extremes equals the product of means. And you will see its importance very soon. But this is it for now. I've managed to hang a scaled up version of the painting in my lounge, and you can hang this medal around your neck that says, I know proportions. I guess we all won today.